Hello, everybody, and welcome to Adler Astronomy Live. My name is Meredith. I'm your host, and today we're going to be talking about the Aquarius Project, which is Adler's teen-driven underwater hunt for meteorites in partnership with the Shedd Aquarium, the Field Museum, and NASA. We have a lot of amazing guests today for our program, but as you might notice, we are not all in the same space. We are currently quarantined in our own spaces. I'm just sitting in my apartment here in Chicago. Because of that, you might get some fun bonus material, such as potentially the incredible construction that is going on outside of my window 8 hours a day for the past 3 months. You might hear some of that, or maybe somebody's child or a pet might jump into screen, or we might have a technical difficulty. Because of that, we just ask for your patience and understanding, and we hope that you are ready to have some fun. Okay, so like I said, we have a lot of guests today, but I'm gonna first start by introducing our Adler experts. With us today, we have Chris Bresky, who is the lead on the Aquarius Project, and he works with the Adler teens in the art of storytelling and the arts. Hi, Chris, how are you?
Hi. Oh man, it's so great to be here and so excited to be on here with you.
Yes, where are you joining us from?
I am joining you from the Adler Planetarium, the Doan Observatory out back. We were able to sneak in and get some of these amazing tools that teens made to share with you all. And we're right here by the lake where these space rocks landed.
I am so jealous. I miss it so much. Thank you for being there. Also with us, we have Geza Juk, who's an astronomer at the Adler and one of the founders of the Far Horizons program, which is where the Aquarius Project was born. Hi, Geza.
Hello. Hi there.
Where are you joining us from?
I am joining us from my ever so humble home.
Yay! Thank you for joining us.
Thank you.
So, everybody, we are this program is meant to be totally interactive, which means that we want to hear from you. You are meant to be asking us questions for our experts to answer. So please utilize the chat function in YouTube. You'll see that Kelly from the Adler is joining you in there. So everybody say hi to Kelly and send Kelly your questions. There are also some Adler astronomers who might be in there answering your questions live in the chat as well. So please utilize it. And we are so excited to get started. Okay, so today we are going to be talking about Aquarius Project, but what we're really talking about is asteroids, meteors, meteorites, specifically meteorites. What is the difference between those objects? Geza, can you tell us?
Yeah, so all of those are space rocks. Okay, big or little rocks floating through space, or at least they were floating through space. And they come from different parts of the solar system. Most of the asteroids come from the asteroid belt. We have a great visualization here which shows the asteroid belt. All those lines you see are orbits around the central sun. You've got Mercury, and then Venus, and Earth in blue, and then Mars, and then all the green asteroids. And every once in a while, some of those asteroids float in, and if they're big, we sort of call them asteroids. If they're smaller, we call them meteors. If they sort of go through the Earth's atmosphere, if they sort of get close to the Earth and dive into the atmosphere and sort of, a lot of heat and burning up. And if they make it all the way to the ground, that's a meteorite. So meteors are in the atmosphere, meteorites on the ground.
Okay, so it's when a meteor makes it to the Earth that it gets that "ite" at the end of its name.
Yeah.
Incredible. Okay, so now that we know what the names of all these different space rocks are, Chris, why don't you tell us a little bit about the Aquarius Project and how it got started?
Sure. Yeah. So imagine a few years back, it's a February evening, February 6th to be precise, about 1:30 in the morning, dark night sky, winter night sky above the Midwest, and this bright green glow lights up the night sky. And it actually was so big that a lot of people saw it. And it was they call it a fireball. It's this big, massive rock from space enters our atmosphere and comes screaming through. Yes, this is a video from Lisle, Illinois police officer was able to get it on their dash cam.
Whoa!
And, right? Isn't that huge? So it looks like it's just over the ridge, right? So the Lisle police officer actually got reports that, oh, we're worried that there's a house on fire over the horizon. But this actually came over Wisconsin. So you saw that from Lisle, Illinois, and it looks so close. But one of the people that saw it, so over 500 people saw this event and reported it to the site called the American Meteor Society. And because I said it was so big, people from all over the country saw it. from Nebraska all the way to Niagara, New York. So you can see some of the people there who reported it from the American News, right? Look at all of them. So this thing was so big, it was seen everywhere, and everyone was wondering where it landed, but we couldn't find anything on the ground. And luckily, we were able to use weather radar. So this is a new technology that's being used for the last couple of decades. We'll have a scientist come in here soon to talk about it, Dr. Mark Fries from NASA. But the same science that is able to predict your weather for the next week can also tell us about rocks falling from space.
Wow.
Yeah. Yeah. So it was pretty exciting. So, like I said, one of the people who saw the fall was an astronomer at the time at the Adler Planetarium, Dr. Shane Larson. And he started emailing back and forth with astronomers at the planetarium, wondering, where did it land? Do we think it landed in Lake Michigan? But we didn't really know. So it wasn't until we saw weather radar, the images from the weather radar, that we actually got a clear idea of if it fell in the lake or not. So I think we can probably pull up the weather radar and see that view. But here, so great. So you can notice this pixelated green and red on the top left. That you might notice that your weather, like on the weather report, sort of coming in this morning, we'll have clouds coming in from the west.
Right.
Well, that night, you can imagine the weather report was partly cloudy with a chance of space rocks, because
Yes.
I know, I'm sorry. Because if you look down, just in between Sheboygan and Manitowoc, off the coast there, up in the top left, those are clouds. Over in the water, those are not clouds. Just the radar can pick up objects moving horizontally, but also vertically through the atmosphere. And that radar bounced off of the rocks as it fell and gave us a readout of where these objects were.
Oh my goodness. I'm thinking about all the people across the country who saw this thing, but also really, I can't stop thinking about how that one person with the dash cam footage got the most perfect, beautiful shot where it went right over the street, like right between those trees. Absolutely incredible. And so cool that we can then pinpoint it using weather radar. Okay, we do have a question that came in, which is, why did the meteorite look so green? Geza, can you explain that?
Sure, be happy to. So two things is, how green would it actually have looked if you're looking with your eyes? And how green does it look to the camera? And cameras aren't the same as eyes, and they're a little more sensitive to green. And so things, unless you've got a camera that's sort of been designed to try to mimic the eye, they tend to make things look a little more green. So that's one thing with that dash cam. But the other thing is that as the meteorite goes screaming through the atmosphere at tens of miles per second, it hits all of this air. Even way up there, there's a lot of air, and it slams into it and compresses it and heats it, and the friction heats it, and that air turns into a sort of a sheath of plasma. And when the air gets that hot, it'll glow. And in particular, the different chemicals will glow in different colors. There's a lot of oxygen, and oxygen is particularly bright when it glows, and oxygen glows green. So you're sort of seeing the composition. Asteroids on other planets, say Mars or something like that, or meteorites on Mars, would probably glow a little bit different colors.
Wow. Okay, so we saw a little bit before about the asteroid belt, and that's where a lot of meteorites come from. Is that where this meteorite came from, do we think?
Yes, it is. If you saw that video before, the visualization, and you could see that there was this, so all these green orbits, those are the asteroids, and they're sort of more or less in circular orbits. But you saw that the orbit of our meteorite was in the white, and you can see that right there. So I'm going to share that. Is really looks very different. It starts sort of one end is in the asteroid belt, but the other end is sort of among the inner planets. It sort of dives in among the inner planets. And probably what happened is at some point there was an asteroid in the asteroid belt, in that sort of green belt, and maybe it ran afoul of Jupiter. Jupiter's gravity started pushing it around, or maybe it smashed into another asteroid, and pieces went flying everywhere. And some of the pieces sort of went flying more towards the center of our solar system. And so our particular meteorite went into this orbit that goes into the central solar system, and basically just kept playing dodge and trying to avoid the planets. It would sweep through, and well, every time it sweeps through, it has a chance of hitting something. And well, one fine day, it got unlucky, and we happened to be there.
Or lucky.
Yeah, I was just gonna say
lucky for
lucky.
us.
Can I say also that image that you just saw? So there are less than 30 falls in the history of astronomy that have enough video data to track it, to have the ability to track it back out into the solar system. And from the work from the astronomer Dr. Mark Hammergren, with the science from the trajectory from that video and other videos taken from this fall, and through the visualizations of Dr. Aaron Geller and Maria Weber at the Adler Planetarium, they were able to create that visualization. But imagine that this fall is one of 30 or under 30 falls that have it. So it makes finding these objects that more precious because we know the puzzle of the solar system that it came from.
Yeah, it's like sending a space probe out there and sampling, grabbing something, bringing it back, except we don't have to have the space probe. It comes on its own.
It came here. Okay, we have a question from Mike who wants to know, how large was this meteorite?
Okay, so you want
sure. So the meteorite was probably sort of, car size, that sort of thing. The amount of stuff that made it to the ground that we sort of tracked on the weather radar was something around 600, 500 pounds. So that's a pretty hefty amount of stuff that made it to the ground. But the original one, what entered the top of the Earth's atmosphere, was, car size-ish, maybe. Depends on the car, of course. It's hard to know exactly how much, because going from the brightness to the size of the object is difficult.
Thank goodness we have our atmosphere to make these things smaller and a little safer coming into our planet and our space. Amazing. So, okay, Chris.
Yes.
Let's talk about Aquarius Project.
Yes.
Tell us about these teens.
Well, I mean, that's the key of ingredients. So as you can already tell, we're talking about NASA, we're talking about people from the Shed Aquarium, marine biologists, and we're talking about astronomers from the Adler Planetarium all coming together. But the heart of this, the driving force of this entire project, are teens of Chicago, Adler teens, and teens from all across Chicago, which is why this is truly so special.
Yeah, okay, we are about to meet these teens. Some of you might have joined me a few weeks ago. We had some teens on our last Adler Astronomy Live that I did. And y'all know that teens are changing the world. They're the most inspirational people in the world. So we're about to meet some incredible teens. But before we do, just in case anybody is just now joining us, we are talking about the Aquarius Project, which is an underwater meteorite hunt being led by teens here at the Adler Planetarium with some awesome partners. If you are enjoying this program, Adler Astronomy Live, then we are asking that you might consider actually donating. And actually, we have our awesome annual fundraiser gala coming up in 2 days, not tomorrow, but the next day. It's called our Celestial Ball. We have it every year. And this is where we fundraise a lot of our money for our amazing programs. So we are hoping to fundraise some more. If you wouldn't mind joining us, Kelly is going to be sharing the link for that in the chats. Please click on it. Please join us September 12th, 2 days from now. Any amount is welcome. It's fully digital. Literally everybody can join. You can donate $1 if that's all you want to donate. That's totally fine. It's any amount is welcome. Maybe you want to donate 600 pounds if you're over in England, or the rough conversion of that, because that's the weight of the space rock we're talking about today. Who knows? Any amount is welcome, and we are just so appreciative to you all. Okay, let's keep going and let's meet these amazing teens. Teens, please unmute yourselves. Join us. These teens have done incredible things with this meteorite hunt. First, I see we have Jack Morgan joining us. Hi, Jack.
Hello.
Where are you joining us from?
I am joining from Chicago.
I love that casual mug shot. Can you show us again?
Yes, this is my Adler Planetarium mug.
Earlier, we told Jack to take a sip and cheers every time he talks, so I hope you keep it up. Okay, also joining us, I see we have Jared Scales. Hi, Jared.
Yes.
How are you? Where are you joining us from?
I'm also joining from my home in Chicago.
Amazing. And then do we have Rome?
We do have one more teen joining us live. We're having a little bit of technical difficulties, but they'll be joining us when they log on again. Rome Jones is joining us from DePaul campus, I believe, in Chicago.
Amazing. See, this is live program. Once again, we ask for your patience. You never know when we're going to have a technical difficulty. Let's get Rome in here, though. But in the meantime, oh, wait, Rome?
Yeah, hey.
I can hear you. I just can't see you. But
That's all right.
that's okay. How are you?
I'm doing great. How are you?
Good. And where are you joining? You're joining us from DePaul?
Yep.
Amazing. Okay, hopefully we'll be able to see your face soon. But in the meantime, let's talk about Aquarius Project. Jared, nobody has ever attempted to do something like this, correct? So, I mean, y'all didn't have a protocol of what you were going to do. How did that feel, and what did it feel like? How did you start?
It was definitely very intimidating to begin with, not having anything to go off of before. We were like, we have no clue what we're going to do, but we definitely just had to stay persistent and work together to figure it out.
Amazing. Looks like we have a question from David from Batavia. Am I saying that right? Batavia. The meteorite that fell in Lake Michigan, was it confirmed? We know that the meteorite fell into Lake Michigan, right? The story of whether or not it's confirmed, and okay, I won't say anything more. We have some fun stuff coming up. I see Chris going like this. We're gonna get there. Let's tell the story.
We're gonna get there.
Yeah, let's tell the story from the beginning. Okay, so you have to start from scratch, right, Jared? And you're like, how are we gonna do this? We have to build some tools. Can we talk about the tools that y'all made? Chris, you have some of it with you, right?
I do. I absolutely do. I can actually, Jared, do you want to describe what this is?
So this is an ROV that was donated to us by National Geographic, actually. And we kind of counterfeited it to make it to our own needs so that we could pick up some hopeful meteorites. So basically this is remote controlled, and we control it from the boat as we drop it in the water. And it goes down to the lake bed. And the idea is, as Chris is showing, is that we would pick up any probable meteorites with the magnet that we attached. Using neutral buoyancy techniques, we would have to put this magnet on so that it would also stay neutrally buoyant in the water so that we could still control it effectively from the boat. And then the idea would be that we float around and pick up any probable meteorites.
Now, is this an actual meteorite, Jared?
That is actually a mock-up meteorite that we made in the lab test.
Did you have a recipe for that, or did you maybe have to make that on your own?
We actually had to make that up on our own. It was kind of fun. We just like made meteorites in a basement.
And they shared the recipe. I think they actually, we have a video we can share of your test, of your dramatic maiden voyage of, what's the name of this ROV again?
The Sled Chamberlain, I believe.
Oh, that's the dive. The ROV's name, you all named. Yeah.
It was Childish Submarino.
Childish Submarino.
I love it. Oh my gosh, what are we looking at?
So this is, I misspoke earlier, this is the Sled Chamberlain actually shipwreck. And this is our test. So we were floating around this, checking it out with our new ROV that we found.
Yeah. And we got invited on NOAA, the National Oceanic Atmospheric Administration's research vessel Storm. They were really generous to donate their time to our team.
Oh my goodness. What did it feel like to be exploring a shipwreck?
It's really cool. It's really fun. It's like something that you never thought you would do. And they just kind of on you. It's like, oh, we're doing this.
Wow. And this is the bottom of.
Whoa.
This is where we got stuck, actually.
Uh-oh.
There's a tether connected to it so that once we're done, we can reel it back into the boat. And this is when our tether got tangled, actually.
No, what a bad feeling.
The snag right there, yeah.
Okay, but you obviously got it back because we just saw it. It was in Chris's hands. Can you tell us that story?
Did, but we're like, oh, we cut the tether, we lost it, right? So some divers found it, came upon it, and were like, oh, this is a cool gadget. It must be worth something. So they contacted NOAA, who contacted us and was like, we found your rover, but they want some prize money for it.
Oh my goodness, that's so rude. It's so rude. These are pirates we're talking about. All right, well, you don't have to tell us whether or not you paid the ransom. We'll just leave that with you all. Okay, Chris, what is it that's behind you? What's that big thing?
Yeah. Please let me show you. Jack, do you want to narrate here?
Yes, so this is our underwater meteorite sled. It is a device that we built to collect the meteorite fragments from the bottom of Lake Michigan. You can see from the shot here the wheels that you can see the pink and yellow colored wheels, and if you go a bit up on the silver circle things are giant rare earth magnets, very powerful, designed to pick up anything even slightly magnetic that they come across. And we use those magnets because our meteorite, from what we know of where it came in the solar system, we predicted that it's around 5 to 10% nickel and iron, which means we can't use, a normal iron magnet to pick them up, but we can use a rare earth magnet, which is why we have our sled absolutely covered in them. And you can see now we have footage from our very first run of the sled, picking it up off of the deck of the boat as gingerly as we can for the first run. And we're about to lower it into Lake Michigan. This was off the offshore of Manitowoc, Wisconsin, on board the RV Niske, which is a research vessel owned by the University of Wisconsin-Milwaukee at their School of Freshwater Sciences. They very graciously agreed to help us in our quest to find the meteorite. And you can see we are raising it up on the crane, because as you can see, the sled is not a small device, and it weighs about 200 pounds. And to deploy it, you need the use of a boat-mounted crane. And you can see we've just gone under the water, and now our sled begins its roughly half-hour-long descent to the bottom of Lake Michigan, which.
Wow.
Thankfully, you guys don't have to sit through and wait. You can just skip to the very end as we're approaching the bottom. You can see we have a depth gauge on the camera, and right about now we hit the bottom of the lake at 84 meters. And you can see we throw up a cloud of silt as we smack into the bottom. And now that we're down, we can start to pull the sled, drag it along the lake bed ever so slowly, and see what we find. And afterwards, once we've dragged it along the lake for about half an hour, we can pull it back up, scrape off any magnetic material that sticks to it, and send it back down for another run.
What are all those white things, Jack?
Those white things are quagga mussels. They are an invasive aquatic species that was brought over in the bilge water of ships on the Great Lakes. And they have slowly begun colonizing the lake bottom ever since they were introduced. You could also see them sticking to the hull of the shipwreck that we explored earlier. They are a problematic, shall we say, species at in the lake, especially since they can cause botulism.
Oh my goodness.
I also want to point out that if you saw, there was like a visor. Actually, you can see it here. That was in front of the camera that both Jack and Rome designed and built, that kept our sled from flying off the bottom of the lake. They were able to innovate that kind of on the fly in between outings to innovate on our sled. And also, we didn't get to talk about how many people had been down there before, Jack.
No one. That part of Lake Michigan was at that point completely unexplored, and we were the first people to get to see the lake bottom, and that's still the only time anyone's been down there. So everyone watching at home, you're still among the first people to have seen any footage from the bottom of that that part of the bottom of the lake.
Isn't this incredible? These young people not only designed from scratch these tools that could go down to the bottom of Lake Michigan and look for meteorites, something that had never been done before, but they also saw a part of planet Earth that literally nobody else has seen before. Unreal. Okay, we have a couple of really interesting questions really quick. Robert wants to know, if it's not metal, like if the meteorite is not metal, then what tool would you use to pick it up?
If it's not metal, then that makes your job a lot harder.
Mhm.
There is a way to do it. You can collect just if we can see on the sled, there's some little baskets on it.
Looks like a hamster wheel.
Yeah, little hamster wheel things that are hilariously called nut wizards because they're designed to pick up nuts that have fallen from trees onto the ground. And so we use them to pick up rocks that are on the ground.
I can demo it really quick. So, you have your team-made meteorite and say it's rolling across the bottom. We're in the strewn field and it pushes in. Now you have your meteorite stuck in there just purely through the tension of these tongs.
The nut wizard.
The nut
wizard. They're very good at collecting material, and that's both a good and a bad thing because it means they collect everything. And so you can find non-magnetic meteorites, but you'll also find everything else. And so you have to try and sift through it once you bring it back to the surface. But it is a way of collecting a non-metallic meteorite.
So cool. Really awesome. Okay, Tia from Prospect Heights wants to know, who represents ownership of fallen underwater meteorites? So if you were to find one, who owns that?
Oh, well, I can tell you that we found out that once something is on the bottom of Lake Michigan for over 60 years, then it becomes the ownership of that state or whatever, whoever the state owns that part of the lake or is in that part of the lake. Who owns a meteorite?
We're hitting the interesting intersection of the law as it regards to finding meteoritic material and the law regarding underwater salvage. And
wow.
Neither of those are areas that I'm particularly familiar with. So I think that might be a question for the lawyers.
Yeah. And some of these, you can also, the astronomers in the chat might be able to help you out with those ones as well.
Luckily, we have a lawyer joining us today. Show yourself. I'm just kidding, we don't. Okay, amazing. So that's still kind of a question mark, but luckily, those aren't things that you need to worry about right now. And then Jim wants to know how big the search area was.
So the search area is very large. The area that we were searching, what's known as the strewn field, because it's a field that our items are strewn through, is roughly, if you look at it on a map, imagine from north to south, it runs roughly from the city of Manitowoc to the city of Sheboygan in Wisconsin, and then east to west, it narrows to a point to the north, and at the south end, it's about 12 miles across.
Amazing. So you have a long way to search. Okay, Chris, I see you. You keep holding up this tubey thing. You're excited.
Yeah, well, we're talking about exploring the unknown, and these young scientists knew that they're on the brink of scientific exploration in general. So when exploring the unknown, you need to create more than just the sled, but something to sense and gain data on the unknown. So Rome, I don't know if you want to tell us what we're looking at here.
That's something I got to design myself. When you go underwater, you really don't know what you're looking for. So you want to take data while you're down there to bring up to more people. So we had sensors testing for dissolved oxygen, the light, the pH, and the temperature to see what kind of environment the meteorites have been living in this whole time, or trying to get them. And that's where I come in. I got to design this tube that it holds all of the breadboards and the wires and stuff so that they don't get wet, or because if they get wet, they don't work. It holds them so they don't get wet and they don't get crushed by the pressure of the water.
Unreal. So is this your first time designing a device that can test for environmental affectations as well as have to survive in high water pressure and take samples? Is this your first time doing that?
This was my first time doing that. I've never worked with a program before. Chris introduced me and was like, hey, I need you to do this. And I was like, I guess I have to figure it out. So this was the first time I got to work with that program, and I really enjoyed it.
How many iterations did you go through before we got this Tubi?
There must have been Tubi. there must have been about 6 or 7. I remember I got to draw up all of the diagrams as I was going along, and I had to measure things in millimeters because if it wasn't exactly correct, the dimensions of this tube were very small. They had to fit very specifically. And if I could, they needed to fit. Yeah. So this is the first time sorry, I forgot what the question was.
No, that's okay. It's in Rome. Jared, Jack, y'all are amazing. So impressive. We just talked about the process of how you started looking for these meteorites. Let's talk a little bit about what was found. And in order to do that, we need to bring on another special guest, but our teens aren't going anywhere. Chris isn't going anywhere. Gaze is still here. So if you have more questions, please type them in the chat. Kelly will get them over to us. Okay, let's introduce our guest coming to us, I believe from Texas. Mark Fries, are you there? Can you unmute your camera?
I
your
am.
mic?
Howdy.
Where are you? Oh, wait, I can see Rome.
Frozen, coming to you from Antarctica, apparently. Let me try that again.
Well, we can hear your voice.
Hear you.
I also saw Rome
Okay.
for a split second.
That'll do, if nothing else.
Hi, Mark. You're coming to us from Texas, correct?
Yes. So I'm coming to you from Houston, Texas. I'm in my house. I work at Johnson Space Center here in Houston. It's the home of NASA's Curation Office and Astromaterials Research Office. And yeah. Oh, there we go. Looks like it's working.
Hi, Mark. Can you tell us about what you do at NASA? Like what specifically your job is?
Sure thing. So I am the NASA Cosmic Dust Curator. In the curation office, we keep all of NASA's collections. That includes the the moon rocks brought back by the Apollo astronauts. It includes material brought back to Earth by several different missions. And the collection I take care of is cosmic dust. Cosmic dust collection, real quick, basically the Earth acts as a giant collector. The Earth receives somewhere on the order of 40,000 tons of material falling on it every year from asteroids and comets. And what NASA does is fly high altitude aircraft with little collectors on them. Most are about the size of your hand, and flies a high altitude and just draws racetrack patterns in the sky, catching this material on the way down to the ground. And then we take these collectors back to the laboratory and very carefully pick off the little specks of dust that have come to us from comets and asteroids that way. So yeah, that's what I do. I collect dust for a living.
You collect dust, but you're not a forgotten toy on a shelf. You are doing some things.
I'm glad to hear that.
So cool. And also, ever since I learned about the nut wizard, I can't help but think like the Earth is like a big nut wizard collecting all this material, and you're learning about what it is. So cool. So how did you get involved with the Aquarius Project?
So all the collectors are all the collectors. Now I've got nut collector, planet Earth as nut collector in my mind. That's going to stay there. All the NASA curators are also scientists, and so we have our job to take care of these collections, but we also have a measure of dessert to do our own research. And my research includes taking all excuse me. Basically, there's all manner of new technologies coming online which can be used to find meteorite falls. And my research is to try to take those and put them to concentrated, focused use on quickly finding and recovering meteorite falls. That includes weather radar data. Weather radars are designed to see rain, snow, sleet, falling things, and it turns out meteorites are also falling things, and it works really well. Here's a good example. This is a composite image of the meteorite fall into Lake Michigan. And what you're seeing, every one of the little blue and gray pixels there is a reflection from falling meteorites. This image is composed of data from 5 different weather radars in the immediate area, all obviously within range of the fall. And you can see, you get basically a picture of a range of meteorites of different sizes all settling down into the lake.
Wow.
Yeah, so it gives what it gives you is a very, very precise location for for where these meteorites landed. You figure your typical meteorite is about 4.5 billion years old. And so this particular one, it spent 4.5 billion years drifting slowly through space, and then came screaming down through the atmosphere and missed land by just a few miles after 4.5 billion years of travel, which kind of that's a little obnoxious if you ask me. But anyway, there it is. I can take these the locations. So the weather radar is reporting the location of all of these falling meteorites, not just over land, but at a prescribed altitude above the ground. And we can model their flight down to the surface from there. And that's what you're looking at here. This is a model result showing where all of those meteorites landed, in this case in the water. And that gives you what's called a strewn field. They call it that because the meteorites are strewn over the ground. They get size sorted on the way to the ground. The big ones reach the ground really quickly. The small ones are slow. They take a longer time to reach the ground, so they have more time to get carried by the winds. In this case, that's why you get a strewn field that's not exactly a straight line. It's a little like banana shape there. The ones at the bottom in yellow are the smallest meteorites, and those were carried toward the east by winds as they come to the ground, as they fell to the ground.
Wow.
So yeah, this is basically what I was able to offer, how I was able to help the Aquarius Project by showing where these meteorites must have at least hit the surface of the water, and then they took it from there to plan their dives, as you can see.
I mean, that's an incredibly important first step of where to look. We have a really quick question for you, Mark, and get ready because it's really cute. This is from Rory, 5 years old in Long Beach, who wants to know, what does cosmic dust smell like?
That's a great question. The answer is I have no idea. It's too small. I can't smell it without accidentally inhaling it. It would be lost. I can tell you that it's probably very similar to meteorites, and meteorites can smell. There's a few dozen different types of meteorites, and some of them smell almost floral, they're rich with organic compounds, and they smell like a combination of like road tar and flowers and chemicals is the best way to put it. Other ones, the ones that are mostly rock, they smell like freshly broken rocks. Like when you break up concrete and you smell that kind of really dusty, almost acrid smell. So that's probably what cosmic dust smells like. Although I've never tried it. That's a great question.
If you had tried it and accidentally sucked it up into your nose, would you admit it to us now or no?
Oh, I haven't tried it.
Okay. All right.
That one's easy because I've never tried it. I wouldn't try it because that would be destroying that would be losing a vital research resource.
Which brings us to our next question from L Tags, who wants to know, what do you do with that dust that you collect if you don't smell it?
So all of the NASA collections are basically a big part of curation is not just keeping these samples and caring for them. They are actively loaned to researchers all over the world. Now, we get thousands of requests for materials every year. Every single request goes through a review panel to judge its merits. Maybe to offer some advice. Sometimes we take a request and say, actually, maybe these samples would be a little better suited to your needs. We work with the scientists to come up with the best set of samples to get their work done, and then ship these things all over the world. The Apollo mission samples, the moon rocks, they are still very actively researched. For example, I mean, they're studied by scientists who weren't even alive when the Apollo missions flew. Many of them using scientific techniques that hadn't even been invented at the time. So we get a lot of science out of these collections, and will for the foreseeable future.
Amazing. Okay, so we've talked about how you helped Aquarius Project find where they need to look. Now you also have been helping with the samples they brought back, and that is where things are about to get so exciting. We have such exciting news. So why don't you tell us a little bit about some of the samples you got back from the Aquarius Project?
Okay. Could you put up the first picture I sent? Oh, here it comes. All right, so the materials as they were picked up off the not the seafloor, the lake bottom, look a lot like this. At least this is what it, let me take a step back. First thing that happened was, folks on the scene there in the Aquarius Project examined the larger pieces, looking for meteorites, and none of those appeared to be meteorites, it's not surprising, actually. It's not unusual that you should have to go to the tiny size fractions to find material, just because it is scattered over a larger area. And the smaller the pieces of meteorites, the more of them were generated. So the best likelihood is you're going to get little tiny pieces. Excuse me. So this is the material as it looked like from the seafloor. Now, what we're looking for, I did it again, the lake bottom. What we're looking for is little melted pieces of rock, basically. And it turns out this site where they collected material is terrible for looking for this material, because it has a large volume of material from the steel working industry, one way or another. I don't know how. Either, maybe it was, slag that was dumped in the lake, or, washed out in the rivers, or it's from a shipwreck nearby. We don't know. But one way or another, there's an awful lot of what's called slag, the melted remnants of making steel and iron, and it's in there. And if you look at these samples, look at the one on the left, you can see little rounded spheres and little melted looking pieces of rock, and that's all slag. That's all terrestrial contaminants. So we have to not just find the things that look like melted rock, but find the things that look like melted rock that came from above, from space, not from a furnace somewhere. And to put this in perspective, the image of the right, that white thing sticking, that kind of yellowish thing there, is the tip of a bird's feather that I like to use to kind of move these things around, and that's for scale. So you can see these little pieces.
I thought it was a pencil. It's even smaller.
Oh, it's smaller. We got to sort through all those little things one at a time, looking for the likely meteorites. It's slow going. Could you move to the next picture? All right, so this is one of the possibles that was picked out. And basically, it's a matter of going through and looking for the things that look like they could be from space, and then looking closer and looking for some of the real hallmarks of a meteorite. This is one of the possibles. This from its texture. This looks an awful lot like a type of micrometeorite called a barred olivine chondrite, or micrometeorite. And if you look at it, it looks like it's made up of lots of little tiny plates of things that are stuck together and stacked together. This might be from space. This is a pretty good candidate. The problem with this one is that what you should see in this is all those little plates have glass in between, and you end up with a smooth sphere. And in this guy, all of the glass is dissolved, which happens over time. The problem is it usually takes a long time for that to happen. So I don't think that this could have happened in just the time between now and 2017. This is probably I'd be comfortable saying this is probably a micrometeorite, but it's probably much older than the meteorite fall. This is part of that 30 to 40,000 tons of material that's just constantly raining down on us.
So you're saying
close, but sorry, go ahead.
You're saying these teens created an underwater meteorite retrieval sled, went 200 feet to the bottom of Lake Michigan for a very specific rock from space, and they found a different rock from space?
An older, cooler one? Not cooler. Not cooler.
Yep.
That is so amazing.
I'm actually not surprised. There are people who, as a hobby or for their own interest, go to rooftops and just collect material out of the gutter of your house and find these things. The little micrometeorites like this fall on Earth, fall to the ground at an average rate of about 1 per square meter per year. So, any house, you've got dozens every year landing in the gutters. So, yeah. So I would believe that's extraterrestrial, but I don't believe that it's from this fall. I think it's a little too old.
You heard it here first. Stop putting off cleaning out your gutters, everybody. Let's see that next sample. I'm so excited.
Yeah, maybe you can collect enough of those to smell them, see what they smell like. Never tried that. They probably just smell like gutters. So. Okay, so this one I'm excited about. Cautiously excited in a very scientific sort of way. This is another sample collected by the Project Aquarius that looks very much like a micrometeorite. Looks like a ablation spheral or material from outer space. You can see that it kind of has the spherical form of a droplet. The thing was liquid, and it cooled from a liquid to form this, but it was also either rotating or decelerating rapidly, and it deformed. And so it's got this kind of bulge sticking out of one side. That's pretty typical for material shed from a meteorite fall or some micrometeorites even, which are individual tiny particles that come in and fall to Earth. So this one looks good. This looks, the shape, the morphology of this looks like it could well be part of this meteorite fall. The really interesting thing is here in the little red circles. If you kind of squint at this and look closely, where it's deformed there, it's exposed a bunch of bright little nuggets in there. And those little bright nuggets are made of nickel. And that's important. Nickel is kind of one of the hallmarks we look for material from outer space. It's not a guarantee, but it gives it a good likelihood, or at least a good probability, that this is probably a meteorite fall or extraterrestrial. And you look at the thing overall, and you can see that this is not corroded. This is not etched. This doesn't have rust coming off of it. There's no evaporite. It looks fresh. So combination of chemical composition that's consistent with meteorite infall and just the general fresh, new-looking nature of this particular particle, I think that this is the best candidate so far for material from that meteorite fall. I think that's there's more we can do to test it, but this is quite promising.
Teens, I don't know if you want to unmute your videos and your mics. I want everyone out there to know that the teens just learned about this yesterday. This is brand new information after all that hard work from years ago, starting from scratch. It all culminates in this moment. How do you feel?
It's amazing. It's amazing that after all this work, we finally found something.
Yes.
I think Jack got it. I think that represents pretty well.
Yeah, it's crazy because there's such a big area for us to get, and things that we're getting are so tiny. And when we went on the trip, there was these huge gallon buckets, and I never thought we'd find them because it's huge. It's so much material. The fact that we actually found it's just crazy.
So exciting. In fact, I think there was a news article about it today. It's just the most exciting news, and we are so happy and proud to be sharing it with everybody. Also, these teens just started college now, so they had an incredible experience. They get to celebrate, start college. I mean, what an amazing opportunity and experience. Okay, so we are low on time, but before we go, we do want to share ways that you can get involved. Of course, there's always a way for you to get involved. So Chris, do you want to talk about the website?
Yeah, absolutely. I want to say congratulations, Rome and Jack and Jared. So proud of you all. You all brought your individual talents to it and made this team what it is. I'm inspired by you every single day. And if you're inspired too, to just learn more about what this all is, how it came to be, like we were saying, this is a very rare fall. And you can track it back out into space yourself on the Adler Planetarium's website. We'll put the link in the chat with Dr. Mark Hammergren's science and mathematics and our visualizers over at the Adler, Dr. Aaron Geller and Dr. Maria Webb. They were able to give you this interactive, so you can go to the view of the asteroid. You can move the camera there. You can move your camera to the site of the impact, and you can track it back. There's 2 years of this orbit after its 4.5 billion year lifetime before that dance finally ends into this impact just a couple years ago. So that's one way to get involved. Another way to find more and to hear more of these rockstar Adler teens is to listen to the podcast. We have our senior writer, Aubrey Henry standing by. Aubrey, you there?
Yes, hello.
Hi, Aubrey. Tell us about the podcast.
Yeah, so the Aquarius Project podcast, if you've all been like sitting here wondering what it's like to be part of something like this, the podcast has been following the project since 2017. So when you listen, you'll hear stuff from 2017 all the way up until a couple weeks ago. It gives you the full story from the inside of the project. And you'll get to know the people that you met today, Chris, Mark Fries, Jared, Jack, and Rome, and also some other people that you might not expect to find working on a scientific research project. There's the police officer who took that dash cam video that you saw earlier. There's a stay-at-home dad in Minneapolis, a Norwegian jazz musician, which was kind of a surprise. Ooh. And all kinds of people came together to make this project happen. And we hope that you'll come away from it with a sense that you don't have to be a scientist to make a new discovery or solve a really tough problem. You might have exactly the right skill or experience or way of looking at the world. The missing piece of the puzzle might be you.
This is so special. Everyone, thank you so much for joining today. Please click on those links, learn more about the Aquarius Project, listen to that podcast. It's so good. If we didn't get to your questions today, we apologize, we ran out of time, but please email your questions to askadler@adlerplanetarium.org. We have, our experts are gonna be answering any questions that come through there. They answer it all the time, and it's actually pretty cool. You'll get a really awesome, substantial answer from a real expert. So please feel free to email your questions. Also, don't forget to join us for C-Ball in 2 days. Kelly is going to be sharing that link again. So join us, and thank you to anybody who has donated so far. We really appreciate you. And also, Kelly will be sharing a link to a survey so you can let us know how we're doing, what you would like to see more of on this program. And please don't forget to subscribe and press the little bell notifications thing on YouTube so that you know when we have another one of these. They're about every 2 weeks, and we'll see you again in 2 weeks from now. So please join us again. And thank you, everybody. Thank you, Chris. Thank you, Jack. Thank you, Jared. Thank you, Rome. Thank you, Aubrey. Thank you, Geza. And of course, Mark Subrow, who's been running this entire program from behind the scenes. Thank you all, and we'll see you in a couple weeks.
Bye.
Bye.
Bye bye.
Oh, so great. Bye.
Hey. Oh, and Mark Fries. Thank you. Bye.
Bye.